The universe around us is as mysterious as expansive. We don't know much about the cosmos, but the things scientists have discovered are quite unsoundable to the common man. Before we reveal what is really going on, take just 1 second right now to hit the subscribe button below. This will help us serve you better. Now that you've subscribed, let us continue. With the advent of science, space, and the rapid technological development of this century, scientists have discovered many incredible things that surely explode in a universe of which we are a small part. Our universe is often compared to a ball of mass full of galaxies, stars, and other giant physical objects. But this universe, in fact, does not conform with this external perspective. To say that it has a mind of its own would not be wrong. How else can scientists justify their recent discovery? Something so mystical and alarming was detected by astronomers that the galaxy we call LR looks like a dwarf compared to our solar system, which is probably like a grain of sand in relation to it. Our solar system is part of the galaxy of the Milky Way. Its name describes the appearance of the galaxy from Earth. From our perspective, the Via Lactea looks like a nebula-like light strip visible in the night sky and seems to be made of stars that are indistinguishable from the naked eye. The Via Lactea is a translation of the Latin word lactea, which means a milky circle. The Via Lactea looks like a thin band when seen from the Earth's surface because the disc-shaped structure of the galaxy is being seen from the inside. Galileo Galilei was the first person to solve this light band at different times, in 1610 with the help of its telescope. Interestingly, almost all astronomers believed that all the stars in the universe were contained in the Milky Way. But the great debate of 1920 between Harlow Shapley and Herbert Curtis, together with the observations of Edwin Hubble, led to the concept that the Milky Way is just one of the multiple galaxies. Structurally, the Milky Way is a spiral galaxy barred with the isotopic diameter d25, estimated at 26.8 to 1.1 kiloparsecs. The spiral arms of the galaxy, however, are only 1,000 light-years thick. Recent simulations produced by scientists also suggested the presence of a dark matter area also, which contains some visible stars and extends to a diameter of 2 million light-years. Our galaxy is part of the local group of galaxies, which forms a part of the Virgo supercluster. This group itself is a constituent of the Laniakea supercluster. The Milky Way also has several satellite galaxies according to specialists. There are approximately 100 to 400 billion stars in the Milky Way and at least the same number of planets. Our solar system is located at a distance of about 27,000 light-years from the galactic center on the inner edge of a spiral-shaped gas and dust concentration called Orion Arm. The center of the Milky Way is an intense radio source called Sagittarius A, a supermassive black hole made of about 4.1 million solar masses. The stars and gases located at variable distances from the galactic center orbit around it at a speed of almost 220 kilometers per second. Scientists think that this constant rotation speed contradicts Keplerian dynamics, and they concluded that much of the mass of the Milky Way is invisible to telescopes because it does not emit or absorb electromagnetic radiation. And this mass is what we now call dark matter. As a whole, the Milky Way is moving at an incredible speed of 600 kilometers per second in relation to the extragalactic reference frames. Researchers have now revealed that the oldest stars in the Milky Way are almost as old as the universe and therefore, probably, formed just after the dark age of the infamous Big Bang. Experts also estimated that the Milky Way is one of the two largest galaxies in the local group. The other is Andromeda. The mass of the Milky Way is approximately 890 billion to 1.54 trillion times the mass of the Sun. So far, astronomers with the help of latest generation equipment have discovered that a lot is happening inside this galaxy. In addition to the hundreds of billions of stars and planets, there are also 10 billion white dwarfs, 1 billion neutron stars and almost 100 million stellar black holes. The space between the stars is occupied by a gas disk called the interstellar medium. A lot is happening outside of the Milky Way too. In fact, recently astronomers detected something extremely disturbing almost 730 million light-years from Earth. It would not be wrong to say that astronomers have a fall due to large explosions and collisions. They are always competing with each other to find a bigger and brighter. And what is better than an explosion produced by two of the largest objects in the universe colliding? In February 2022, a new study was published in the Astronomy and Astrophysics magazine, which presented the world one of the most detailed images ever captured by a huge shock wave. The Able 3667 is the name given to a cluster of hypnotizing galaxies. It is actually composed of two groups of galaxies colliding with each other. In fact, Able 3667 is home to 500 individual galaxies, which are slowly agitating in a huge cosmic soup. The enormous shock wave detected by scientists is a consequence of the fusion of these two galaxies. At this moment it is not clearly visible to most telescopes, but this cosmic collision produced a huge wave of disturbance in the region. Experts described it as a colossal shock wave that forms at both ends of the cluster, which merges and is only visible in radio wavelengths. Researchers used a set of telescopes, MERCAT, located in South Africa, to visualize the radio relics of both halves of shock waves. This study revealed that the structures are much more complex than specialists believe. According to the author of the main study, Francesco de Gasperin, a visiting scientist from the Hamburg Observatory in Germany, shock waves work as accelerators of massive particles that accelerate the electrons at almost the speed of light. The waves are inserted by an intricate pattern of bright filaments that trace the location of the giant lines of the magnetic field and the areas where the electrons are accelerated. This shock wave can be a recent discovery, but it certainly isn't. In fact, it exploded for the first time almost a billion years ago, when two galaxies that constitute Able 3667 collided for the first time. The galaxies are among some of the largest gravitational structures in the entire universe. And when two galaxies merge, they release an equally huge amount of energy. Researchers think this is the largest amount of energy released in a single event since Big Bang. The collision event fired an electron wave a billion years ago when the agglomerates collided, and even today these particles are still traveling at an incredible speed of 1,500 kilometers per second. When these particles pass through magnetic fields, they emit radio waves. These were the radio waves that Dr. Gasperin and his team observed along the MERCAT. Radio waves alone were not enough to characterize the shock wave. The XMM Newton X-ray Observatory also invested some time studying the Able 3667. If you look closely at this image of the Able 3667, you will notice the white color in the center. This is a concentration of 550 individual galaxies. But the red tones on each side represent the shock waves formed during the creation of this supercluster. This discovery is considered a game change in the field of study focused on the understanding of the fusion of galaxies. But this is definitely not the only surprising thing found in outer space in recent years. An astronomical team led by Chong Ji from the University of Alabama, Huntsville, used the XMM Newton X-ray telescope from the European Southern Observatory and the Multi-Unit Spectroscopic Explorer on the Very Large Telescope and the Subaru Telescope to conduct this study. They discovered a huge hot gas cloud, slightly bright in outer space, which is much larger than the Milky Way galaxy. This is a single cosmic gas cloud, and it is possible that it has moved away from a galaxy. The surprising revelation was that, instead of dissipating somehow, this cloud had managed to stay stuck for hundreds of millions of years. After analyzing the X-ray emission, the team of researchers concluded that the cloud was even greater than they initially predicted it would be. According to them, this cloud has a mass of about 10 billion times greater than the mass of the Sun. The physicist Ming Sun, from the University of Alabama, said that this discovery shows that new surprises are always out there in astronomy. The study called it an orphan cloud and also showed that its temperature varies between 10,000 to 1 billion Kelvin. This temperature is consistent with the gas found within the galaxies and therefore solidified the theory that the cloud pulled a galaxy while it moved through space. Dr. Sun also revealed that the cloud was found in Able 1367 or Liu cluster, which contains almost 70 galaxies. It is located about 300 million light-years from Earth. Scientists were interested in discovering how gas did not dissipate despite having been removed from its galaxy for so long. These calculations revealed that a magnetic field is capable of holding the gas cloud against instabilities for a long time. It is only logical to assume that, from the mass of this cloud, the galaxy from which it detached was also extraordinarily large. The team of researchers is optimistic that this cloud can help them track their mother galaxy. These data will also help scientists identify other similar clouds in the future. Scientists consider this cloud to be observational evidence that favors the assumption that the intracluster medium can dispel galaxies from its gases. Sometimes the absence of everything ends up being a bigger dilemma for scientists than the presence of something strange. In 1981, the astronauts at the University of Michigan were trying to calculate the redshifts of a large number of galaxies. They created a 3D map of the universe. As the map was being filled, they realized something strange. About 700 million light-years from Earth there was a huge void, a region approximately spherical, with almost 330 million light-years of width, was taken back to the researchers. This void could fit into the Milky Way a billion times, but there was still almost no galaxy here. At first it was called Great Nothing, but later it was called Void Bulls. This was because it was apparently in the constellation of Bulls, the man of the herd that drives the Arad around the North Pole. Many maps detailed the universe were created since then. And we now know that most galaxies are found in long forms of structures called filaments that circulate through the cosmos. These filaments exist with huge voids and few galaxies. It turns out that these voids make up about 80% of the observable universe, and most of these are 30 to 300 million light-years away. Boots is one of the largest voids out there, and that's why it's called supervoids too. Some scientists believe that many smaller voids merge to produce Boots. But why do they exist? Well, in the early times of the cosmos, the matter of the universe was well packed, like a uniform soup. However, random quantum fluctuations began to create small differences in the distribution of matter. Because of this, some areas became denser than others. This meant that their gravitational attraction was also greater, so that they removed the matter from the less dense area. This made it even denser, and so on. The universe was expanding at a fast speed, and at the same time that the fluctuations that began at a quantum level soon extended for hundreds of millions of light-years. The smaller tufas began to organize in galaxies while the vacuums continued growing. Such discoveries end up helping scientists to win a window to what the universe looked like in its first moments. Although the revelation of more and more secrets of space is also terrifying, it is only proof that we know very little about the universe without thinking in the circle, but specialists believe that no amount of fear should prevent the acquisition of so much information about the outer space as humanly as possible. Do you agree? Tell us in the comments.